Hello. Welcome to ActionNET tutorial provided by Spin. In today's video, you will learn about DNP 3.0 protocol settings. This driver is used for communication with intelligent electronic devices, IEDs, that use the DNP 3.0, Level 3, protocol. Communication can be done through multi-point serial channel, or using Ethernet local area network. And TCP/IP protocol, in which case, each IED has an IP address. In DNP, information is organized into data types, where each data type represents an object group. Within each object group, there are variations that are used to indicate different methods for specifying data within the object group. For example, the analog input group accepts data such as 16-bit integral values with signal, 32-bit integral values with signal, or 32-bit floating point values. Within these groups of objects, there is the class group, which is object 60, with 4 variations, that are: Class 0, it is used to read all static points, analog and digital. This is a verification reading, and should not be done too often, once the IED can have thousands of points. Class 1, 2 and 3, corresponds to state transition events of points associated, specifically, for each one of these classes. Not all equipment has these classes, but most do. In protocol option, there are 9 types of settings. 1. Link confirm mode, protocol mode in which, in the link layer, all requests receive confirmation response from their reception. 2. Accept unsolicited DNP, checking this option as enabled, causes the master station to send a message of enable unrequested messages to the slave station when starting the channel execution, immediately after the request of class 0, and each time the master receives an indication of restart in the internal indications field. 3. Master station ID, number corresponding to the master station address. Thus, a master when sending a message to a slave, informs his address. Some slaves respond to the master disregarding this number, others require that the address declared on the slave be the same as that of the master. Number between 1 and 65,534. 4. Quality changes timestamp, checking this option as enabled, causes that when a new reading of an object is received, with flag, even if there is no change in the status, or value, of the tag, but there is a change of quality, change the tag's current timestamp. 5. Generate log file, checking this option, causes a log with information of messages exchanged, and several actions, taken by the communications module, to be generated in the ActionNET directory. 6. IED time bias from GMT, in ActionNET, internally, all timestamps are stored with GMT, UTC, dates. IEDs, usually, send these dates also in GMT, and no correction is made. The default for this option is 0. If in the current deployment the IEDs send the timestamps in their local time, the difference between this time and GMT time must be specified here. For example, in Brasilia the local time is 3 hours shorter than GMT. For this case, -3 should be specified in this table. 7. Password for commands, to increase the security in sending commands, usually initiated only by a change in the state of a tag. It is possible here to specify a password of up to 9 digits, which will be checked by the communication module against the current value when the command is received, with the estimated value attribute of the tag involved in the command. So, in the operation of sending a command through a window, script, etc., this number must be loaded in this attribute. Leaving this option with 0, verification will not be done. 8. Synchronization LAN, indicates the synchronization method to be used by the driver, according to the device with which it communicates. Choose Enable to use the LAN synchronization method. It is usually marked Enable if the communication will be using Ethernet. 9. Timeout, MS, waiting time, in milliseconds, to receive a response after sending any request. The settings options, if the communication is using TCP/IP, are: share node same IP, accepts IEDs with the same IP. Use single thread, use a single thread. Use ping to check connection, use the ping command to check the remote server. Invalid values, invalid values. The settings options, if the communication is serial, are COM, number of the communication port, used in the computer. Baud rate of the communication. Data bits, size of data bits, per byte. Stop bits, length of stop bit, per byte, 1, 1.5 or 2. Parity, type of parity, even or odd or none. The three next attributes are used to control the message flow between computer SCADA and IED. DTR, if the data terminal ready control signal is on, the SCADA is informing that the DTR control signal will be used to control the flow of messages. RTS, if the request to send control signal is on, it is informing that the SCADA computer will always send a request to send control before starting to transmit a packet of data. CTS, if clear to send is ticket, the SCADA computer will wait a CTS signal from the IED before send the packet of data. In timeout, we set time limits for transmitting and receiving message characters, and the number of retries until fault, TX, time, in milliseconds, for the first bit to be sent. RX start, time, in milliseconds, between the last byte sent and the first byte received. RX finish, time, in milliseconds, for message to be completely received. Next byte, time, in milliseconds, between each received byte. Retry, number of attempts, before failure, in case of successive timeouts. Unsolicited, maximum time, in milliseconds, without unsolicited communication before setting error. The initial state defines how the channel will start, enabled or disabled. If the channel is disabled, no messages will be sent or received through it, that is, the channel will be inactive. In the Nodes tab, there are other types of settings. For the case of communication via TCP/IP, IP address is the IP address of the IED server and must be specified. Port number, used for connection in any case. Slave ID, address of the IED slave, at the application layer. Ignore bit online, if enabled, indicates that the driver should ignore the bit online indication that is inserted by the IED when a fault or abnormality occurs at one point, according to the IED criteria. Wait for idle to command, if enabled, indicates that a command will only be sent when the communication is idle, not occurring. AI sample time, MS, time, in milliseconds, between two consecutive requests of analog inputs, request for type 30 objects, all variations. By sample time, MS, time, in milliseconds, between two consecutive requests of binary inputs, request for type 1 objects, all variations. Class 0 sample time, MS, time, in milliseconds, between two consecutive requests of all points parametrized, reading consistency. Class 1 sample time, MS, time, in milliseconds, between two consecutive requests of Class 1 list of changed points. Class 2 sample time, MS, time, in milliseconds, between two consecutive requests of Class 2 list of changed points. Class 3 sample time, MS, time, in milliseconds, between two consecutive requests of Class 3 list of changed points. Counters sample time, MS, time, in milliseconds, between two consecutive requests of all counters points, request for type 21 objects, all variations. Time date sample time, MS, time, in milliseconds, between two consecutive synchronization requests. This is the request of the current date and time in the IED, object 50. It only happens when the computer time is synchronized by the IED. Tag for COM status, insert the name of an existing tag that will be used to receive indication of success, failure in communication, from a functional point of view. When requests are made, the module waits for a maximum of timeout milliseconds, defined in protocol options, above, to receive a response. In case of failure, the value of this tag will be set to 0. In case of success, the value will be set to 1. The same settings, made for the master station, can be made to a backup, alternate, IED station, if it exists in the installation. In the Points tab, the points can be of input or output. The input points, that is, the points that are read by the protocol, basically, have two main parameters, the type of point and its address. There are 12 types for the point. The implemented point types are defined using the data objects defined in the standard. The output points, used for commands, have a control code parameter, in addition to the type and address, to specify the output operation. Clicking on the right arrow shows the window with the attributes selected for the current value. If the user changes the selected attributes and presses the return arrow, a new value associated with the selected attributes will be generated. There are several attributes possibilities for the control code, as you can see in the table. In addition, there is also more possibility for function code, which is the definition of the operation to be performed on the command. All command points must have write as access type. The internal indication type indicates status of command responses. These internal ID status indications are reported through flags on the objects transmitted in the communication. In order to receive the IN, an integer type tag with type IN and address 65,000 must be defined. This tag will receive the register with the 16 bits, where each one of them means some ID condition. Thank you very much for your attention. See you in the next ActionNET tutorial, provided by Spin. If you have any question, please contact us.